Welcome, everyone. I'm Melanie Kreff. I'm the scientific officer of the Global Seaweed Coalition, and it's a pleasure to guide the discussion today with you. So today's webinar is about celebrating our awardees that realize fantastic projects and that get funded by the coalition through call for proposals. So all of them are here to support the safe and sustainable development of the seaweed field in the Global South, actually. So, but first, I will give you a few words about the Global Seaweed Coalition. So we are a global partnership hosted at the United Nations Global Compact, and we are supported on science through the French National Research Center, which I actually belong to. We received an initial funding of the Lloyd's Register Foundation to fund those projects that we'll be presenting today, amongst others. So we support the safe and sustainable development of the seaweed industries as it scales up, while also acting to act on preservation and reforestation. So we do that through 4 action pillars. We've got funding, and we seed projects like the one we'll be presenting today. We do advocacy, meaning we spread the narrative seaweed in different forums at local, global, and national level. We have a science and technology pillar where we share expertise, innovation, technology, mainly through workshop with the support of a scientific council that is doing actually a good and intense work when it comes to the call for proposals. And lastly, on policy, we try to influence policy change at a global level. So now we have reached more than 1,200 members that represent people across the seaweed value chain. That can be research institutes, multinational businesses, startups, intergovernmental organization. So it's very broad, and so we've reached a good outreach, I would say. And so one of our key action, as I mentioned before, is to animate call for proposals, and through that we managed to finance 32 projects across the globe, so on all continents and in 27 different countries, and those projects receive altogether 1.5 million euro. So those projects usually focus on consumer safety, food safety, or environmental safety, and topics are actually very broad because it comes from taxonomy, biodiversity, biosecurity, to seaweed farming, capacity building, social businesses, seaweed valorization, and way more. Also, we try to put most of our efforts in the Global South because this is where we can have a stronger impact when it comes to sharing best practices or to have a stronger impact on sustainable development of the seaweed industry. And I'm very glad that today we're going to be focused on Southeast Asia projects and African-based projects. Through the process is actually very competitive. So this year we received more than 100 applications that got reviewed by our scientific council. So our scientific council is a group of scientist experts based around the globe, from Australia to North America, Europe, everyone, every country is represented. And so they review the 100 application, and then we had a second layer of review with our strategic advisory council that are more people based on institution and based with an industrial background. So out of the 100 application, we selected 8 awardees. And today we will present 4 projects out of the 32 projects. I don't know if you follow the numbers, but out of the 32 projects we have granted so far. So I will give a quick round of introduction before the project owner get to present their presentation. So first we will have Callum Mackenzie presenting his project at Yunus Thailand. Is a social business that focused through our first grant in 2021 to deliver cultivation kits to smallholder, mainly women, that were very affordable, $200. I double checked, and with a quick break even. So it was a nice on the side for those smallholders. And this year is growing and going further into this project, trying to deliver a more value-added product out of the colerpa they are cultivating, and a part of the income of those production are actually going to capacity building, and so to generate more seaweed farmers. Then we will move in the Philippines, where actually Nick will introduce from Cause for Sea, will introduce typhoon platform resistant to cultivate seaweed. They have tried to cultivate Akema and Capaficus on a platform which is a ring shape, and facing some challenges going through this cultivation method. So he will share that with us and sharing his results as well. Then we will follow and we will have a 10-minute Q&A on those two first projects based in Asia. And we will move to Africa, where first in Madagascar, where Manon Museux, based in Nociboa Seaweed, will introduce how she used drone and data monitoring on a very well-organized seaweed farm to optimize process and production. And last but not least, we will have Paula Sacher, based in Namibia, that will introduce a study with Kelp Forest Foundation. Kelp Forest Foundation has been a pioneer when it came to biodiversity impact of a kelp forest using environmental DNA method. And this year, with the new grant, they will focus on how a kelp forest can mitigate ocean acidification at a local level. So very exciting. We'll then follow by another 10-minute Q&A and close the session at 2:30 in CET time. So last word before we get in the substance of the event, I will invite you to ask your questions through the chat while the project owner are presenting. And we want to give a word about the internet connection, because we mentioned Philippines, Madagascar, Namibia. All those countries has sometimes unstable connection. So we might have to deal with unexpected live events. So we'll try to adapt at best. So without further ado, I think I will give the floor to Callum and maybe Azedine to share the video of the first project. Thank you.
I'm ready to share.
Brilliant. Thanks so much. So I'll share some words first, but Azedine, yeah, I really appreciate the support in sharing the video. Yeah, thanks so much for the opportunity.
Amanda, I think you are not on mute, so we can see you very well. Amanda Root.
Can you all see my screen?
Yes, yeah, fantastic. Fantastic. Well, hopefully everybody could manage to see the video fully, and yeah, thanks for the love heart, Lisa, as well. Yeah, so that's a pretty good summary of what we're up to and what our project kind of focuses on. Maybe just to add a couple of key points that I think are crucial to complement the video. I think the first one to mention is that we're not trying to kind of revolutionize the way seaweed is grown or cultivated. I think we're not trying to replace open water cultivation, but this is something that can complement, on one side, people who have open water cultivation and allow them to have all year round crops. Or on the other side, people who are completely new to seaweed and completely new to the sector can, in a very easy way, start a seaweed entrepreneurial journey. So in Thailand, this is the group of people that we've focused on, since the sector is very, very, very nascent. So the 50 women entrepreneurs, they've had no prior experience to cultivating seaweed, with 2 days of training, and these are basically some of the poorest women in the area. Some of them, can't really struggle with reading and writing, but after 2 days of training, they're able to cultivate seaweed successfully. And in terms of their daily time inputs for these modules that we've had, you're looking at around 15 minutes a day to run this business. So it's a really good complementary kind of side income, which also builds a lot of economic resilience. And then on the other side, through this kind of improved quality of cultivation as well, we're seeing a 230% increase in price per kg compared to local markets. So that's a pretty huge thing. This is just with the fresh raw product. And in some cases, it's still early days, but in some cases, we're seeing people doubling their monthly income, having only needing to work an extra 15 minutes a day. So the opportunity here for transformation is quite exciting. I think the key thing that we're seeing here as well, which the video mentions, is then how do we also add in these value-added products and the processing aspects, and make sure that communities are benefiting from this next stage in the value chain as well, and making sure this is as inclusive as possible. I think this is for two reasons. One, to basically also keep on increasing that income generating potential. The other side is to make the logistics aspects and the supply chain aspects much more scalable, so we can reach more and more people, because the Callurpa fresh produce has only a 1 to 2 day shelf life as well, so it makes longer supply chains harder to manage. So this is some of the things that we're really trying to work on here, and so we should have a nutritional analysis coming back very soon of all the different nutrient benefits, which will help us kind of further innovate the product development process. So that's kind of ongoing at the moment. And I think also a seaweed drink is one thing that we're really looking at, because it leverages the point of kind of the high water content in seaweed. So that means that it can, that we're not losing a huge amount of mass from that. The other side, the health drink range is a really health drink sector is a really fastly growing sector as well. So looking to tap into that, but we'll also look at other value-added products as well. Seaweed salts, like we've seen working with other species in other areas, for example. I think over time, the nutraceutical and pharmaceutical markets and extract is also an interesting one to look into too, as well, for Callurpa as well. I think just another point to mention in terms of our projects as well is also how we're trying to, on one side, demonstrate and kind of lead from the front in terms of a seaweed social business model that is open source. We want to share this with as many people as possible, right? So people can replicate this. But on the other side, how can we also be a kind of an even more of a team player and really strengthen a kind of a seaweed social business sector here as well? So we had a seaweed social business forum about a month ago, which sees some very friendly faces here who took part in that. And we're really, through this project, creating a seaweed social business community of practice as well. So we really invite everybody here to join, and we want to participate through a participatory process, kind of develop a kind of a mandate and a roadmap for what this community of practice can do, and more importantly, what value can it bring to people. And we had, from that first forum, I think virtually every single person who attended signed up for the community of practice as well, or an intention to. So I think there's a really exciting mobilization aspect that's coming into this as well. I'm also not actually joining at the moment from Thailand. I'm joining from Philippines at the Social Business Day International Conference. And so this project has also been presented on the main stage as well as in plenary sessions as well. And we've had a huge kind of positive response from this as well. So a number of kind of leading microfinance banks across a number of countries are now getting more and more interested in developing specific seaweed microfinance products as well. So this is also the exciting thing about this second aspect of our project, that we can really have this kind of open innovation process and that can really support and strengthen the movement as well. So, and also our big boss, Nobel Peace Prize laureate, Professor Mohammed Yunus, he's a full convert seaweed fanatic now as well. So, I had even a Japanese corporation come up to me today and say Professor Yunus was telling us to get into seaweed. So this kind of thing. So hopefully this kind of high level advocacy aspect can really support the work as well. So we've got a project plan, but we're also a little bit infamous for kind of adding in extra bits as we go along as well. But hopefully it's all kind of positive stuff. And final point, we'd just really like to invite everybody to come and visit us in Thailand. The place where this is happening as well is absolutely gorgeous. So it's a great opportunity for a seaweed holiday, if you like, that can also have some educational benefits as well. And please stay in tune for the kind of the formation of the seaweed social business community of practice too, because from the people I recognise and our fellow grantees in this call, there's so much expertise, so much value in the insights that everybody can share. So we really want to, build this as something as meaningful as possible, and that really relies on your participation and insights. So I'll leave it at there. Really excited for any questions, so please bombard the chat box, and I'll pass over to my fellow grantees.
Thank you very much, Callum, and for making the effort to join from the Philippines, as I'm sure you have a very busy planning right now. So we'll pass over to Nick, which is based in Australia actually, but running the project in the Philippines. So Nick, over to you.
Fantastic. Thank you, Melanie. Can you see my screen?
Yes, very well.
Everybody? Excellent. Thank you. And thanks for that, Callum. That was wonderful to see and hear. I'm afraid, shame I'm not in the Philippines to come and see you there, but I might take you up on that holiday offer in Thailand, seaweed holiday offer. Case 4C, we're going to run through quickly who we are as an organization, and then get into the project that that was funded, very kindly funded by the Global Seaweed Coalition. I see I've got the wrong old logo in this presentation. Apologies for that. And run through some of the results and findings from that. So we are a solution to quality, responsible seaweed in quantity, and we're working primarily in the Philippines with Southeast Asian species, particularly euchematoids right now. I'm trying to change the slides as well. We all know that seaweed demand is growing extremely quickly. It's a big market out there, and it's growing really quickly. And I'm not going to go into the details of that to this audience, but there's also this problem, this challenge with the slowdown in growth, despite the fact there's more seaweed farmers now than ever before. And there's also a decline in the quality and the sustainability of the seaweed, which is really creating a bottleneck in supply of material that meets ESG and quality criteria. So we came in to try and help solve that problem, create a solution for that problem, and we do that by aggregating and partnering with thousands of smallholder farmers to build that supply of quality, responsible seaweed in quantity and to meet the needs of responsible global brands. So we're kind of market agnostic. We sell at the moment primarily into the carrageenan market, but we're also looking to and talking to kind of new emerging markets anybody that's interested in seaweed that's got ESG metrics and ocean protection metrics associated with it, please do come and chat with us. And we're looking at different species and things that the farmers can grow. We really see it as it's a smallholder industry that we're working with. We're trying to empower and work. We've got two customers effectively: the people that we sell the seaweed to, but the biggest and most important customer is ultimately the producer, because if the producers aren't doing well, we're not going to do well. So it's really that, with that kind of focus in mind. There's a big problem with the way that seaweed is being produced, traditionally, particularly as eukaryotes, in Southeast Asia at the moment. There's been this very little investment into that production. 90% of the tropical red seaweeds are being produced in Philippines and Indonesia. So it's a lot. There's many thousands, hundreds of thousands of seaweed farmers involved. But there's been no they're using outdated technologies. In the face of climate change, using outdated strains. There really needs to be an uplift in kind of how things are being done. And that's driving some poor practices, such as the use of single-use plastics, but also high risks on farms, very high levels of mortality, that's partly because of the high risks. The old adage that's the shadow of the farmer is the best fertilizer, because there should be no other fertilizer added. If there's very high risk, people will, within their diversified livelihood portfolio, they'll put the time and their effort into fishing or something else instead of seaweed farming, which becomes a negative cycle. So we aim to address that challenge. We provide a farm input package together with called the Grow program to farmers. That's based on R&D around improved production practices, but importantly also improved behaviors on farms, particularly around biosecurity. And that leads to improved outcomes, much reduced mortality, people making more efficient use of their space. However, we're still kind of constrained, particularly to the shallow water nearshore areas. So about 5 to 7 meters depth maximum. Those are becoming increasingly affected by climate change, becoming increasingly crowded as well. And obviously, seaweed farming is highly vulnerable to typhoons, particularly to typhoons. So we were actually hit by Super Typhoon Odette within months of kind of our incorporation and setup, which is, a bit of a shocker. It's not our first super typhoon, unfortunately, but this one went right over the top of the team. Mads, who's on the call, was right in the middle of it. That building, the bottom left, he was trying to kind of look after that building, and I was messaging him saying, "You've got to get out. This is bigger than we thought it was." And so it caused a huge amount of damage. It took out, massive, everybody's homes, basically 80-90% of people's homes are destroyed, but it also livelihoods were massively destroyed. What's been super interesting is that since Super Typhoon Haiyan, which was 2013, a huge amount of loss of life, we've learned a lot, not just Coast 4C, but the country more broadly, about disaster risk reduction plans. And there was a lot less loss of life in Super Typhoon Odette. But the next thing is, how do we help protect livelihoods? And seaweed farming is a really important one. All the seaweed farms were wiped out. There's very little biomass left from which to build from. So we wanted to create a project to help increase that resilience around that. So that led to the project Safe Seaweed Relief, and prototyping a typhoon-resilient platform restoring biomass in the aftermath of Super Typhoon Odette was the title of the project. And we teamed up for this with the Climate Foundation. So the Climate Foundation have been doing some fantastic work around developing systems and structures, particularly ring-based, raft-based structures. Effectively, they could put out in the open ocean, very deep waters, where there's not much nutrients. So they have to solve that problem by doing some depth cycling. They could take the seaweed down to depth at night time to get the access to the nutrients and bring them back up. And they've seen some fantastic success. But that's really been. Oh, sorry. Was that a question? No, it was maybe so. So there's been fantastic success with that. And what we thought was we know that the Climate Foundation platform survived Super Typhoon Odette. So we thought, can we pilot the use of this ring in and near to seaweed farms, maybe without the depth cycling, in major seaweed producing areas to help increase the resilience, but also to help accelerate and maybe put it into areas that are kind of a bit further offshore, slightly deeper. There's been a big push, people talking about expanding into the deeper, cooler waters because of climate change. Could we do that with this ring and add the typhoon resilience and accelerate the biomass grow out to help restore people's livelihoods on Danahan Bank? So this is Danahan Bank in the central Philippines. There's double barrier reef. There's not much deep area there. Even the white areas, there's maximum depth of about 15 meters. This is the ring that the Climate Foundation provided for this project, which was fantastic. I do have a video. This is a schematic. I have a video The sound isn't going to work, so I might try and talk to it. And we're not going to watch the whole thing, because it's 5 minutes, but just to give you a quick overview. So this is effectively a demonstration of the submersible ring that they set up in deeper waters. And really, sorry, I can hear the audio as well, which is very distracting. And it's a really nice, simple system that you can quite easily take your boat out to when a typhoon is approaching. You can unclip the ring, and it sinks down to about 5 meters below the surface. And then there it can ride out. It can ride out the typhoon. So there's some very nice video here. I can share that later, as we can't hear the audio. Maybe it's not so ideal. Let me move on there. Oh, so we wanted to test it in this location. This is on the Danahan Bank on the Double Barrier Reef. This island here is Mahanai Island that I'm circling here. All these shallow areas. This is the kind of shallow reef areas around it with mangroves nearby. This is a major seaweed producing area. There's quite crowded space. There's Gindakpan here. There's a lot of seaweed farming happening here. The distances aren't that big from tip to tip here. It's about 5 or 6 kilometers. And this is a reef which is with some farms in different spots along that as well. So we thought, let's try do this in slightly deeper water where it should be cooler. There is access that, maybe it can accelerate the biomass grow out there, and then we could sink the typhoon sink the ring if a typhoon comes along. We were expecting, given the location and surrounded by lots of seaweed farming areas, that the nutrients and everything else should be relatively amenable to seaweed growth in that area. It's just with this infrastructure that gives us the ability to grow in that space. So we tested effectively the growth of the seaweed in this deeper channel area versus the shallower grow farms, where this is the farming methods that we've been supporting farmers to implement. A couple of different farming methods there, using a variety of different species and also varieties of eukaryotoids in the ring in that deeper area, compared to kind of the standard what people are using at the moment. They won't accept all the other types of seaweed because of the survival, or the market isn't good enough for them. So they're mainly using Vanguard. But we tried it, which is the type of Capophycus striatus, variety of Capophycus striatus. But we tried a few different varieties in the ring, including spinosum, Euchaema denticulatum, Capophycus alvaretsi, Capophycus striatus, and a few different varieties within that as well. So I'm not going to go into huge detail on this, but effectively there's a lot. We measured growth rates, daily growth rates we tagged some plants in the ring and in the farms. And we measured daily growth rates for those. There's about 140 tags that we were monitoring in different crop cycles. And we'd go out and weigh them every week, basically. And then from that, we could calculate daily growth rate and all sorts of mortality and other things. This is a kind of a summary in terms of the total weight of tagged plants from planting through to the end of each of those crop cycles. On the left, you've got the deeper water ring graphs. On the right, you've got the results from the grow farms. And what we found was a bit of a surprise to us, in the sense that it seemed really hard to grow seaweed, even that very small distance out away from where the other traditional seed farms are growing, as soon as the water gets a little bit deeper. So the water depth underneath it was about 15 meters. You could see the reef slope kind of nearby to it, very close nearby to it, and not far from that, you've got seaweed farming areas and mangrove areas and so on. So this wasn't expected. We weren't able to measure nutrients. I think that would be something that'd be really interesting to further explore. We were only able to do a few crop cycles and things as well, because of the time frame of the project and things. But I think there's a lot more that we can do in terms of experimenting with the location setup, taking it into shallower waters and so on, and looking at how we can move it out of the shallow waters afterwards if there's a typhoon coming along. So there's a lot more that we need to do in here. But I think it was a really interesting learning for us that basically for most seaweed species, there was actually a decline in the quality of the biomass as soon as you get into just over 10 meters of water, basically, like around 15 meters of water depth. So it shows how fickle these seaweeds are, how much we've still got to learn about them. The only one that did show some positive potential signs is spinosum, the brown type of spinosum, that showed a little bit of growth in the ring in the deeper area in the second crop cycle. But generally, it wasn't as good as what was happening in the grow farms. The top one was cycle 1, that was during the main growing season. The bottom one was towards the end of the growing season. You can actually see on the bottom right-hand side, there's a dip in about mid-January, which was there's biological cues to show it's the end of the season because the seaweed starts to ball up. You don't get the sprouting branches anymore. So that happened in the second half of the second cycle for the grow farm, but elsewhere it was we were getting sort of 4.5 times growth on planting biomass for the grow farms after 45 to 55 days. In a cost benefit analysis, I think the ring is a prototype at the moment. It is definitely going to be a little bit more expensive than the traditional setup. However, just looking at this, even as a prototype, looking at material setup costs, things that obviously there's some other pieces in there as a prototype, but as material and setup costs, we're estimating it'd be about around $1,300 compared to about $650. At the moment, you can only plant about 10% of the planting biomass in each of compared to the grow farm for that amount. But we know the Climate Foundation are working on more scaled solutions that will be much more cost effective, and that will be fantastic to implement. I think that it has an opportunity there to really kind of make the cost effectiveness much greater. So there are some operational challenges as well that we learned quite a lot about. Kind of how do you do maintenance in the ring, especially in those kind of shallower water areas. There's a lot of oyster growth that happens on the thing. There's getting into the ring. We've actually got to get within that structure and get into and look after the seaweed. That's a few things that we could fine tune with some further testing. But particularly, we really need to look more at the locations and setup. The benefits obviously can be typhoon resilience. It could be moved relatively easily, and it opens up those new areas for production. Alongside that, we also looked at, okay, what else could we do to increase typhoon resilience? And we worked within the communities to establish DRM plans, effectively disaster risk mitigation plans, including a seaweed evacuation plan. Not only, there's a few different strategies. We don't want to put all our eggs in one basket. These super typhoons are particularly damaging. So we created this quite detailed seaweed evacuation plan, crop evacuation plan, together with community, collaborating with communities. We summarize that in a flow chart so that when a typhoon's coming along, it's quite easy. People can quickly follow that and make decisions. And those have been integrated into the DRM plan. So now people, as well as kind of protecting lives, they can think about, because we're getting better at forecasting these typhoons, how can they actually protect their crop? You're not going to be able to protect everything, but at least if you can protect something, it's better than everybody going out, than like thousands of people going out trying to gather a few kilos of seaweed out of the mangroves that they can recover after a super typhoon. We also know that actually seaweed straight after the super typhoon actually grew really well. We just couldn't get sources of seedling. There's all this turnover, a lot of nutrients in the water. So the seaweed was growing well, but it was a very, very small quantity of it. So if we can protect a larger amount through these crop evacuation plans, then the chances are we'd have a much larger starting point to go with and be able to get people's livelihoods up and running a lot more quickly. And what was really interesting that we learned as well is there's a lot of money that's thrown into rebuilding people's houses, but a lot of people, they really were worried about their livelihood. They wanted to get their livelihood back because it's great having a roof to live under, but if you don't have anything to eat, it doesn't help you as much. As well as that, we distributed about 36.5 tons of seedlings to 85 households and six barangays. That's about 430 kilos of seedlings per farmer. And we're still building up the biomass. 60% of those guys scaled their farm to about 1,960 kgs of planting biomass. That's the kind of what we call one full module. So that's quite a big. They got to a good size, and the rest are about 40 to 70% of that size, which is not bad considering how bad the seaweed market has been the last year, post-pandemic and all the rest of it. They're trained in improved farming practices as well, and we built those disaster risk reduction plans into it as well. So yeah, in terms of conclusions, I think there's still a lot more work that needs to be done. I think really one of the things we've kind of started to unpack is this whole idea of let's move into deeper water. It's a lot more complicated than that. It's fantastic to see the work that the Climate Foundation are doing, looking at depth cycling and deep cycling and things like that to help address some of those challenges. We're also planning to work more with the Climate Foundation to think, what can we do closer to where those mainstream seaweed communities, those smallholder seaweed farmers are doing to help improve that system, improve the production and open up new areas, whilst improving the typhoon resilience. So thank you very much.
Thank you, Nick. And I think it's really interesting given the cyclone, typhoon that we see coming everywhere, whatever it's called in your country. I think we need to find more solution. I've heard the one from Tanzania recently. That was the first one. They were quite a lot of wind as well in Madagascar in April. So yeah, very interesting. And I think we have some question actually in the chat regarding
fantastic.
your presentation, and that Dr. Brian von Herzen have done some good work at answering most of them.
Excellent. Brian's from the Climate Foundation, so we're working with Brian.
Okay.
On this.
Yeah, actually, one of my questions is about the Climate Foundation. Is it a ring? And where is it located? And what is the size?
Yes, we have a 1,000 square meter ring off the island of Cebu. It's located in the Comodo Sea, and our current depth is almost 200 meters. And every night it cycles down beyond 100 meters, absorbs nutrients, and at sunrise it rises up and absorbs sunlight and carbon dioxide in the top meter of the sea. And about a quarter of the seaweed falls off the platform during growth and sinks about 1,000 meters a day to the deep seafloor. And we measure that as a potential carbon removal. But the prime market, of course, is food, feed, and fertilizer. And we're presently just completed an overhaul, and we're looking to enlarge this. We may be at 2,000 or 3,000 square meters later this year.
Okay, wow. Thank you.
Pleasure.
So the question from the chat have been answered, but is there any net underneath the ring? I wonder if the ring system would be useful to avoid grazer like turtle and fish. So you answered that it avoids it, I believe. There is usually no net beneath the ring. Yeah.
Yes. We do occasionally use a net to just measure the seaweed falling off the platform. And we do see an occasional turtle or fish or whatnot. Our larger platforms, we don't see, I mean, there's some predation, but we kind of, from a permaculture design standpoint, I wonder if some of those other species are actually helping the seaweeds. You know, I think Nick brought up the apt point that it could be the habitat or lack of habitat that could be affecting the ring in 15 meters of water. We don't know if it's habitat or nutrients or depth or something else. But I think some of those other species might be important as well in managing the seaweed. So it's hard to say, you know, and permaculture design principle is you want to build a healthy pyramid, if you will, that can include seaweed and maybe some herbivores and some predators, you know, all mixed together. So that may be important as we go forward, and it'll be interesting to see.
Unfortunately, there's not many turtles in that part of the Philippines. One day, hopefully. So we haven't had to contend with that yet.
We have a video of a little turtle, but he was hanging out offshore, but not too often.
Then you need to do biodiversity study to see if it brings more turtles.
Yeah, good point.
We do integrate, one of the ways we make sure it's regenerative is we integrate the seaweed farming in the traditional seaweed farming, the farmers that we work with. We integrate it into improved marine protection. So there's much larger, there's each community, the communities that we work with, they have a larger, what we call IMPA, locally managed marine area, whatever you want to call it, integrating the seaweed farming into it. They've got no-take replenishment zones, they've got identified areas for sustainable seaweed production, and then other sustainable use areas as well, such as hook and line fishing, etc. And that whole thing helps to de-risk the production. Obviously, the idea is to restore biodiversity. So as well. So as that biodiversity starts to come back, we might see a bit more predation that we need to be looking at.
Yeah, and Melanie, we get a lot more biodiversity with an upwelling platform. We've seen thousands of sardines, hundreds of tuna fish, dozens of dolphins for more than a month, and even 2 whale sharks. But it was mainly when the platform was there at the surface 24 hours a day, and we'd bring the water up to the platform. That's when we saw the most biodiversity.
Yeah, it must look like a DCP that will concentrate all the activity.
You know, we're convinced that it grows more fish, and we can do that with isotopic studies, stable isotopes that will begin next month, to show not only is it aggregating fish, but it's growing more fish with more fish habitat and more primary production.
I will definitely catch up with you then after this call to understand your methodology.
I'll leave my link in the chat.
Is there any other question related to the project in Thailand or in the Philippines? You can raise your hand if you have any. And Azedine, if you can help me go through the chat, I don't want to miss any question from the chat, but I believe it has all been answered.
Yeah, Melanie, your question was for the 0.1 hectare that prototype ring was. It was about 192 kilos that we put on there. I think you could look at different stocking densities as well. But obviously the larger scale, when Brian answered that question, I think there's much more seaweed that you can put on there.
Yeah.
That's the
With
planting
1,000 square
biomass, and
meters,
obviously it
probably
grows
a couple
4 or
of
5.
tons. Yeah, we're looking to put out 3 tons or so on our next deployment.
Yeah, which
For-
is similar, if I'm correct, Manon in Madagascar. I think 3 tons is more or less what you will produce in one module.
Yes, this is what we have now in the good season.
Okay, so that's great to see that it's just not a prototype and that it's really consistent with what's happening on the market. Rohan, I see your hand raised. Please go ahead.
Hi again, hi everyone. Hi Nick. I was curious about the whole design of the ring system and moving into more deeper waters and with the comparative data from the shallow culture areas. What was your biofouling impact in deep waters compared to shallow waters, if you don't mind?
Well,
Thanks.
in the areas where we put it, there's quite a lot of oysters and things like that. But I think Brian probably be best placed to answer about the deeper waters, the open ocean waters situation where he is.
Yeah, I think we can get a lot of biofouling. It's still a concern. I think there's more area on the polyethylene pipe, and so you'll get some more biofouling there. We have had sea cucumbers and other things living on the side there, so it's been quite a variety. And some of we're looking right now at a submersible rectilinear rope structure as well, and that of course would have less biofouling, just whatever's on the ropes. So it's still a problem offshore, and it's something that has to be paid attention to, I'd say.
I think, yeah, and I think in those channel areas, you probably get a concentration of that. So we had a lot of hydrozoids, barnacles, oysters. Very good growth rate. It could be a secondary crop, Brian.
That's great. We just need to find the high value ones, maybe some sea
Yeah.
cucumbers, right? I actually do really like the multi-trophic, if you could have 2 or 3 species running at once, I think there's good potential there.
Philippe's getting excited, right?
Okay. I don't. Any other question, or shall we move to the African-based project?
I have question.
Okay, go ahead.
Hello. Yeah, okay. Hello, Nick. Nice topic. You have 3 species, right? 3 species in the seaweed, and how to identification the species is exactly make sure the species is right. Okay, maybe
Yeah,
like that. Yeah.
so there's the Euchaema denticulatum and then the Capophycus species. And it's quite easy to distinguish between the two of those. And then it's kind of, there's within the Capophycus species, the 2 main ones, there's more other species as well, but the 2 main ones are Striatus and alvarezii. Most of what we see growing in the central Philippines at the moment is Striatus. And if you go out to some of the other areas down south and out to the west in particular, we're seeing more alvarezii. The thing I keep being told by the scientists at the University of Philippines that we work with, Doc Mikey, I don't know if he's on the call as well, that it's not a reliable way to identify them from morphology. Even Striatus and alvarezii, you kind of think you've got your eye on it, but an idea what it is. But certainly the variety names, they vary from location to location wherever you are, and they don't particularly seem to correlate to any particular haplotype. But I can send you some schematics that basically show the difference between those 3 species.
Okay, nice. You use only morphology. Maybe you in the future you need to molecular approach for
Yeah, I mean,
identification.
you can do that, but I mean, when you're doing it at scale in the open ocean, then it's a very fluid system. It's useful to have an idea of what is growing, and you can do some sampling. But actually trying to, from a market perspective and all the rest of it, it's not such a big challenge as long as you're not mixing up the spinosum and cotonae. But I think actually tracking, we've looked at ways that we could try and track the different species in the sea. It's a very fluid system, or the haplotypes. It's a pretty difficult task to undertake. You can do some testing to get an idea of what genetic diversity is, and I think that's probably the best approach. But if you actually want to know this is haplotype X, this is haplotype Y, at that sort of scale, it's going to be highly inefficient.
Okay.
Thank you.
Okay. No. Okay.
I
Thank
think
you. Thank you, Nick.
we are ready to move to the next presentation to keep with the time. So Manon, I will let you start for the Madagascar project.
Yes, let me share. I hope the sound is good for everyone.
Yeah, it's perfect.
Yeah. So thank you for having me. I'm a bit new in the seaweed family, so I'm still learning a lot. And today I will start presenting how we manage the seaweed farm production through drone and spatial monitoring in our company. So the company is the Nosibora Seaweed in Madagascar, and yes, sorry. So I will first start with some generalities, so you understand how what is the place of the company in the Sainte-Marie in Madagascar, and then I will talk about the new technologies we use that the Global Seaweed also financed. So, quick history. Oh my God. Okay, sorry, it's a bit weird. I will change my the diaporama, sorry. It's weird.
I think Manon, you can just put it as a PDF and we'll go through it.
Yeah, yeah.
And if you don't manage, I can
Sorry.
share the presentation you sent me. Worst case.
I will try, but I'm not used. Okay, maybe now it will be better. It won't be full screen, but let me do like this. So a quick history of the seaweed culture in Madagascar. So as you can see, it has a lot of challenge through the story. There were several introduction of the strains. Capaficus alvarezi in 1998, and in 2026, Chema spinosum and Capaficus cottoni from Zanzibar. But in 2010, there was a big outbreak of HEFA, and that drastically reduced the production. So it's in this context that the Nosibora Seaweed Company chose to come in Sainte-Marie, which clearly had good parameters for the seaweed culture. As you can see, it's a small island in the Indian Ocean that has a good, lagoon in the east coast, in the southeast, and the water temperature mean is 27 degrees. Now we are in the winter season. As you can see, there are two seasons. Between May and October, it's the season where there is a lot of rain, there is a lot of wind, which makes it difficult to work in the lagoon, but which is also good for the productivity. This is why we have a lot of good numbers now. And out of the 250 hectares of usable space we have, we use only 35 now. So this is for the location. The model is simple. It's a bit like what Nick presented. We are in the center of the model. We are the link between all the actors that use the lagoon. We are the link, so we are able to bring some seaweed expertise. We are able to look for financial capacities with, for example, the help of the World Bank, of the Global Seaweed Coalition. And also we work with our customers. We have the help of the NGOs and technical partners. And of course, because we are well implanted in the island, we are the link with the seaweed producers. So the seaweed producers see us as like a service provider to help them to produce in a more sustainable way. And this is the cycle they try to follow, which are with our help. So first goes the seedling on the lines, then the planting on the farms. We let the lines grow for 5 to 7 weeks, and the maintenance is done by the farmers, which with the material we give them to go on the field. We harvest and wait when the seaweed is wet, and then there is a selection of the good algae that goes on the seedling lines for another cycle. The other part is for drying. So that's it for the cycle, and these cycles made us made a good production the last year, and is doing well also this year. So these are some key figures from the as of the 1st of June. So we are proud to be collaborating with more than 100 seaweed farmers. We are now giving 80 permanent jobs, which is good for the economic and social integration in Sainte-Marie. Most of the people live with less than $2 per day. So the fact that there are a good monthly revenue, it's very good thing for us. And we are now in the 1st of June, we are over 5,000 tons of wet seaweed harvested, which represent more than 300 tons of dried seaweed. In 2005, we aim to be more than 1,000 tons of dried seaweed. So all of this, we still have some points to work. We still have some things to improve, but it's very encouraging for us to have these key figures. As you can see in this next graph, the evolution of wet seaweed we harvested, the last year. There is, of course, a seasonality. Like I said, we have 2 seasons in Sainte-Marie, but you can see an improvement of the production that goes with an improvement of our practice. And these practices, I will be presenting them now. So we work a lot on our spatial management, organizing our farms. As you can see, there is a diversity of farming cultivation methods in the world. There is a lot of different way to organize them. That depends on the field, that depends on the means you have. And we choose to organize in a certain way our farms. This was the site in 2021, in July. There was nothing in the lagoon, as you can see, some test lines on the side, but now we are proud to have this, which is very well organized, as you can see. And yeah, so what is our farm structuration? You can see a block of farms on the left, and each farm has what we call 6 modules that are with a distance of security between modules and farms. And there is a reason to all of these. We did that because all the spatial optimization we did is also a way to enhance our production. The more we are space between left, the more we can install new farms. Also, there is biosecurity distances that we try to put, and that we'll be working on more. This also is a way to balance all the users of the lagoon. There are tourists that are going through the farms. There are fishermen that are still in the lagoon. So the distances of security are a way for them to go through the farms without any problem. All of these bring a standardization between all the farms. We can compare the farms that are in the north of the lagoon and the farms that are in the south. So statistically, it's like duplicates. It's more interesting to analyze them. And of course, last but not least, it enables us to use new technologies like drone and sensors. All these organizations made us more strong. The use of drone. Here you can see a picture on the bottom of what you see when you're on the ground. So you clearly see a large area, but you don't see really where are the problems or where the farm is destroyed. With the drone vision, you can really spot where the modules are destroyed, where you have to target the intervention. So it's not a waste of time, it's not a waste of money. So it's really helpful for us. And last, the space is constantly evolving. So it enables us to monitor the change of bathymetry of the biodiversity, because we keep an historic of all these panorama we do every week. And so it's very a tool we use every week in our farm. The second new technology that we implemented with the help of the Global Seaweed Coalition is the installation of these sensors. So they are really important to measure the physical and chemical parameters around our farms. And lead us to understand the productivity, choosing the strategic areas where is cooler, where the DO is higher. So it's very helpful for us. And finally, it's an important way for us to gather data in a zone that there is no data yet, and it's important for us to study the dynamic of the area. So globally, this spatial management is still with potential. Depending on the material you chose, the installation can be costly, because it's important to choose something that will last in the time. The frequency of maintenance after every storm, we have to replace the farms that are destroyed, or the things that are not well in place. And the drone cannot be used in all conditions, of course. When there is a lot of wind, we cannot use this tool, which is very annoying for us. And but there is still potential, because linking this drone information with some AI for density analysis will maybe allow us to do some productivity analysis and forecast. And also we can also display this information, all the information we will gather in a portal that will be very useful and friendly user for us to manage our farms. And the last element that can be important in these tools is the master data we are creating, which will be useful for everyone that wants to work on the lagoon in Sainte Marie, or to global more important work. So yeah, we still have some work to do, but there are very important tools that we use nowadays. Thank you.
Thank you very much, Manon, for this presentation. And I think it brings a lot of insight on how to manage the seaweed farm. And good to see that drones are actually really useful and not just a gadget, and that really support your weekly harvest planning, basically. So.
Yeah.
So yes, thank you. So if you have questions, please raise them in the chat, and we just transition to our last but not least project with Paula, which is based in Namibia. Paula, are you here?
Yes, I'm here. Hello, everyone.
Yes, perfect. We still got lucky with connection. I'm very glad. So, are you able to share your screen? Perfect. The floor is yours.
Okay. Good afternoon, everyone. Thank you all for being here in this webinar to listen, taking the time out of your busy day. Okay. So my name is Paula Zachias. I will be talking on my Master of Research project, which is fully funded by the Kelp Forest Foundation and the Global Seaweed Coalition. It's titled Assessing the Potential Impact of Cultivated Kelp on Ocean Acidification and Oxygenation at a Kelp Cultivation Site here in Lüderitz, Namibia. I am supervised by Dr. Hay and Ms. Johnson here at the University of Namibia, as well as from Dr. Cornwell, who is from New Zealand. Okay. Okay, so today, I'll talk about a bit about the foundation itself, the Kelp Forest Foundation. They have a Blue House Fellowship program, which I am a part of. And I will talk briefly about the eDNA baseline study that was done by a previous cohort that the Global Seaweed Coalition also funded. And then I'll talk a bit about ocean acidification and the study that we plan on doing here. Okay, this is just some biodiversity photos that we took here in Namibia in this study site. Okay, so the Kelp Forest Foundation is a nonprofit organization and they have a Blue House Fellowship program. This fellowship program is fairly new, but they have so far fully sponsored Namibian students to do their Master of Science Research project, and I'm one of them. They're focused on filling the gaps in cultivated kelp farms specifically in the ecosystem services that Macrocystis perifera might offer. Some students have looked at the net primary production, specifically looking at the dissolved organic carbon, the biodiversity aspect of the fauna and algal, the macroinvertebrates, and the different marine animals around the study site, such as the birds, the seals, even the phyto and zooplankton. Another student is looking at the nursery and spawning processes within the kelp forest. And then now I will be talking about the potential impact that the cultivated kelp may have on ocean acidification. Hopefully it could alleviate ocean acidification. And all of this is to establish baseline data on kelp forest here in Lüderitz. So on the previous study, that was also funded by the Global Seaweed Coalition, we used environmental DNA, which was made available by Nature Metric kits. Very simple but effective way to get a quick snapshot of the different types of macroinvertebrates, aka the biodiversity present within the farm. I've worked with these kits. You simply pump the water that is in the site through this filter. We then package the filter and then send it over to Nature Metrics to count and identify any of the macroinvertebrates present. This is a snapshot of the data that was found during the study. A lot of types of macroinvertebrates such as mussels, jellyfish, lobsters were found within the site. And it was able to give us, we did this because it was able to allow us to track before and after deployment of the cultivation site, the impact that the kelp might have on the biodiversity. But the previous cohort, which is Angelique Dowd, would have a lot more to tell you about this, but yes. And then on to ocean acidification. I'm sure a lot of you have probably heard of ocean acidification, so I'll just give a brief overview. But generally, it is because of the consequence of the extra CO2 generated in our atmosphere due to the carbon-based fuels that we continue on using. In the early 20th century, we did not obviously emit as much carbon dioxide, but as we entered the 21st century, we've emitted a lot of carbon dioxide through all kinds of industries, and scientists have realized there's a dual reaction, sort of a chain reaction to that, and that is the global decline of pH within our oceans. So with this excess carbon dioxide emitted into our atmosphere, the pH in the global oceans reportedly have gone down, as well as the calcium carbonate ion availability. And this is an important component of building the base food chain of a lot of calcifiers in the food ecosystem. Ocean health and human health are very much interconnected. You can't have one without the other. The other can't. Well, the ocean health is directly affected to human activities, and human activities are affected by the ocean health. Specifically, as the ocean keeps absorbing the excess carbon dioxide, it becomes more acidic, and this directly affects the food chain by harming the marine species, especially the corals, phytoplankton, and a lot of oysters and mussels. Now that's the base of our the marine ecosystem food chain that directly affects the biodiversity within the species, and which directly affects us as humans through our economies and our food security. Specifically, fisheries and tourism is affected once you have biodiversity loss. And since our global oceans cover 70% of our Earth's surface, it also affects the oxygen production. So it is imperative for us to always try our best to work on possible nature-based solutions to protect the future generations. And one such strategy is being proposed, and that's carbon removal, specifically through blue carbon. And it's generally just the idea that kelp and all other types of seaweeds may be able to draw down carbon through photosynthesis on a very localized scale, but still might have a potential impact. The blue carbon works through photosynthesis. The idea of blue carbon works through photosynthesis of taking in the excess carbon, thus raising the pH levels, as well as the calcium ion carbonate availability and the dissolved oxygen. So getting all these benefits from kelp and other seaweeds is important to look into to try and mitigate ocean acidification. And this has a direct link to the Sustainable Development Goals, specifically 12, 13, and 14. The kelp is able to take up excess nutrients as well as carbon dioxide through its photosynthesis process. And it is also able to create ecosystems through its structures of being a habitat forming shelter for a lot of the species. And to go on to the study site, I mentioned in the title, the study is being conducted in Namibia. I'm not sure if you all know where Namibia is, but Windhoek is a capital city and I'm from there. But since being awarded the scholarship, I've been living in Lüderitz, which is where the cultivation site is and where the study is being conducted. In this region, you have a lot of upwelling happening. A lot of upwelling, which does create pH variability, but the site is perfect for growing kelp. And so it begs the question of what is the pH variability? How much does the pH change, or the alkalinity, or the dissolved oxygen with the kelp present? And also, Lüderitz is a very small town. but it is beautiful, and a lot of the people here depend a lot on the fisheries sector. So yeah. And a little bit about the cultivation of kelp. It's done by Kelp Blue. They have no input of fertilizer or fresh water. So they're essentially not harming the environment. An interesting thing about this, they cultivate Macrocystis perifera, which is a big brown algal species that forms a canopy at the surface of the ocean. And what they do is they simply trim the canopy and they harvest it to make biostimulant. And as you can see on the top right there, they use a biostimulant to grow crop, and it also improves the soil health. As you can see, the gentleman on the left here is holding a plant that was grown with the biostimulant compared to the control plant without the biostimulant. And Kelp Blue also has a marine monitoring division that they continuously monitor the water quality and ecology within their farms, just to always know what the impact of the kelp may be in the environment. Okay, so the objectives of the study for my Master of Science research is basically to investigate the potential of the cultivated kelp on ocean acidification by specifically looking at the pH and alkalinity levels. And second, to see how far does the photosynthetic effect of the kelp on the water quality extend by means of looking at a halo effect. There's this picture over here. And then third but not least, we're also going to have a physiological aspect by looking at black mussels grown within the farm and comparing them to other black mussels outside of the farm to see if there is any significant difference in their calcification rates. Okay, so the procedure, just a very simplified procedure overview, will be thanks to the Global Seaweed Coalition funding, we'll be able to acquire on-site autonomous sensors that will be able to measure the pH, the DO and salinity, and in all other parameters. We will then also, along with the autonomous sensors, we'll also have discrete sampling, which we'll do at the lab. Once we get the discrete samples, we run them through a filtration method. This is because it's been stated by Andrew Dixon that the phytoplankton remember this is an upwelling region with high productivity. The phytoplankton may disrupt the pH and total alkalinity measurements. So we run them through filtration first, then we'll analyze them for total alkalinity and pH. And then for the calcification rates, we'll deploy shellfish lines, and specifically using the buoyant weight to measure any difference in the shell weight of the mussels. And yeah, just to recap on the potential impact of blue carbon on ocean acidification, it can raise the pH, the calcium carbonate ion availability, as well as the dissolved oxygen, to possibly alleviate ocean acidification on a local scale. So with that, I want to thank you all, and yeah. Thank y'all. Any questions?
Thank you very much, Paula. And I think one last bit of the protocol you didn't mention is that you will, or maybe I missed it, weigh the calcification on the mussels on the lines to see how they grow better inside the forest and outside the forest. But maybe I missed it.
No, I just forgot to mention that. But yeah, we'll be deploying the shellfish lines and within the forest and outside the forest at different spatial regions. to see if there's any significant impact on their shells.
Yeah, it's interesting to mention because there is a similar topic, a similar study going on in Chile, as you know, and they're gonna do that so that we can compare data, and that's what we like to compare the study at a global level. Before I leave the floor to the live question, there were a question for you, Manon. Our local community members trained to operate the drones and carry out the monitoring services?
Yeah, it's a good question, but for the moment, it's only the NBS staff because we only have one drone, so it will be difficult for us to train everyone. And also because to use the images from the drone, you have to have a phone or a computer, which honestly in the village, in the community, it's not something everyone has. And maybe with the production they have this year, they will have, but for the moment it's not the case. So no.
And just to add on this drone monitoring, what's very interesting is, so every week, since the site is gathered in one place, you just need to do two big picture, and you have all the farm that are captured there. And they cross-cut the data, so the technician will go at sea and see, okay, this module needs to be harvested, but there is a double check with the drones based on the density, so the color you see on the picture. If it's very dark, it means there is a lot of seaweed and the module needs to be harvested. That's basic, but that can save a lot of time when you know how many hectares the farms is actually.
Yeah, it's very difficult for our staff to go every day in each farm to see how much it weighs. But with this drone, we can see the density. Of course, we want to be more precise in the future. We are already working with the ERD, for example, for some photographic methods to understand the density. And it will be very helpful for us in the future.
Callum, I see you have your hand raised, so maybe you want to react to what she's saying, right?
Yeah, no, I mean, thanks so much for the extra information, and just maybe a short idea that came to mind was, over time, for the sustainability aspect of it as well, it could be, you know, one young entrepreneur in the community who gets a microfinance loan, who then is the service provider for other people as well, so that, and you know, they get some training on how to use the laptop or the phone and the drone system, and then they sell the services to the different farmers. But yeah, just thinking out loud.
Yeah, that's a really good idea. Yeah. And I think in Sainte Marie and in Madagascar, people have the skills to do it, so it won't be a problem actually.
Yeah, I
Thank
think
you.
it's very relevant, especially if there is different site also, when you can have one specialist in one village thinking of ocean farmer, that can be very useful. And then on the investment question, Manon, it's true, very impressive work from 2021 to now. In 3 years, what you have achieved. And I think that's thanks to a strong spatial planning that you've done. But I'm sure you can ask the question to Sébastien Jean, who is the CEO of the company, and get in touch with him because he has a lot of experience in the red seaweed field.
He will be more able to answer this question, I think.
Any other question from the group?
We had a
Well, I just wanted
question.
to mention that
Andres
along the
from
lines
Dublin.
of drones, I think there's great potential to utilize daily drone data from farms around the world to actually estimate the daily growth rate and even the daily fall-off rate of the seaweeds. So there's a good opportunity, I think, to pool the data so that we could actually get a larger database and actually develop maybe an open source tool for doing estimation of growth rate and fall-off rates during storms.
Yeah, that's a good insight for one tax for the Global Seaweed Coalition, for example. I would love to have that, but yeah, I add it on my list.
Wonderful. We've proposed this to NASA and some other organizations. We're waiting to hear back to get support to actually do this, the study and the analysis.
But what's very true, we heard a lot more study that where drone pictures are linked to AI, and that's what Google is doing with the Kelp Forest Alliance, trying to Google Australia actually, if I'm correct, to measure the amount of kelp biomass globally. So that's an interesting partnership and another way to use satellite or drones image.
Yeah, I think we have a huge opportunity to embrace drones for cultivated seaweeds, and would love to help to coordinate those databases and develop the training that can be done to develop automated tools for estimating daily growth rates and fall off.
This can
Any
also.
other question?
I was just going to add as well, this is also very interesting from a microinsurance perspective as well. When you start having these bigger data sets, then this can also build a lot of resilience for farmers as well.
Lenny, I think there was a hand up earlier from Tofon.
Yeah, sorry that I missed that, Tofon. Do you still have your question on? Might have left. I actually have a question for Kelp Blue. On the biostimulant project you mentioned, how far are you on developing this project out of the kelp farm? We can call it farm now.
For Kelp Blue, they've been producing biostimulant for a while now, and they have been sending it overseas to a lot of farms, and they're also doing a lot of trials at the moment.
Okay, so but do you have a partner to deliver this biostimulant, or is it Kelp Blue making the product itself?
Yeah, it's more Kelp Blue than KFF.
Okay.
Yes.
Great. Well, we have 5 minutes to the end, so I think if there is no more question, Amado, you get the last one, and then I will do the closing remarks.
Hi, Manon. I'm Amada from the Philippines. I'm just very interested to understand. You shared with us a photo of the area before the farms were set up. So I'm interested to understand what was the involvement of the local community to inform the spatial planning. So you have such a very nice setup. Then the second question I have is, so what's essentially the involvement of the small farmers? Are they do they have a share of the income, or are they paid laborers of the farms? Thank you.
So I'm not sure I understand very well the questions, but I will try to answer them. So the first question, if I'm not mistaken, is how the local community took the farm structuration, right? And actually,
Sorry for the confusion. So I was asking about the area where you're doing farming is really nice.
yeah.
I'm just curious about how the local communities were involved in the planning, how that area will be used for seaweed farming.
Okay, so the every farmer, we work with an association which is called AVA, and each farmer who wants to take a farm in the zone has to sign a contract with this association. So we are not their boss; they are independent. We are just providing them the lines, the tables to dry the capaficus, and also the seaweed expertise, so they can work in an efficient way. And that's how we work. We actually we give them services, and they sell us their production. We only have to remove a small amount to do the seedling again for them, and then that's how it works. So they are very independent. They just follow. We do a lot of meetings with them. Every 2 weeks we have a meeting with them, explaining them how we work and what are the different problems. So that's all.
They're actually owning quite a good salary on average on the island. I was lucky to visit Saint Marie for a month, and the people having a seaweed farm are the wealthier people on the island.
Yeah.
So, which is very good news. Okay, I have to really wrap up now to make it to the hour. So thank you very much all for your presentation. It was very interesting, and I'm always super keen to hear more about your project. For the other, I also invite you to watch our other webinar that are more science-based on carbon sequestration, on methane reduction. You can find some, but I think we'll keep awarding our project because it's very great to hear from you as well. And I think there were an announcement on a forum, Nicola, that you wanted to say. So I will leave the floor for 1 minute to you.
Thank you. Opportunity for a promo here, and Callum had some inside information on it, so he already put something in the chat. We, the Global Seaweed Coalition, is partnering with UN Trade and Development and with the World Bank and the Aquatic Blue Food Coalition to put on an official high-level political forum. The UN reviews certain SDGs, certain sustainable development goals every year. And they do it at this high-level political forum in New York. And we are putting on an official side event. We're really proud that we're doing this. We've got a lot of support from our partners on it. We would love it if you could attend. You can find the link to register through the link that I posted in the chat. It is an UNCTAD or UN Trade and Development website. There's limited in-person attendance, and because there's only space for about 40 people in the room. We're really looking to get potential funders aware of the seaweed sector and of all the great work that you're doing through this event. So do attend the event, be very active in the chat. Encourage, if you know of funding partners, encourage them to attend the event. That's going to be really important. And we're going to be hoping to get a lot of member state representatives in the room that day. So if you know of, if you've got those connections, please get them to reach out to their New York partners so that they come into the room. Thanks a lot, Melanie, for letting me do the promo. And thanks a lot to you all. I've got to say how impressive the work you're doing is. It's wonderful to be a part of it. Thanks a lot.
Nicola, one question for clarification. Are you saying that there's also online participation on this event, or only 40?
Very much so. We expect massive participation from the seaweed stakeholders to be chatting a lot, to be saying how you see seaweed contributing to the SDGs under review, which are ending poverty, ending hunger, climate, peaceful and strong institutions, and partnerships. It's SDGs 1, 2, 13, 16, and 17. So if any of you are so inclined, please go to those SDGs, do a deep dive into the targets and indicators. And if you see opportunities in the chat to say, hey, I know that seaweed can do this, my member state, Madagascar, Namibia, Philippines, Indonesia, this is how we can achieve the SDGs through seaweed. Please do that.
That's great. Yeah, well, if you have the coordinates, that'd be wonderful, so we could learn how to participate online. And of course, SDG 14 is near and dear to our hearts with life below water.
I know, but 14 is not under review, so it's a yes and, but the link to register, you can do it through the link that I posted in the chat. It takes you to a web page where it is the only place where you register. So I have given you the unique way of getting in.
Lovely.
And-
Thank you, Nicola.
And Azadine has given you the chat, given
The
it to
link
you.
again. Perfect. Thank you, Nicola, for making this announcement. I think the most we have people on board, the most we can have seaweed say it out loud at this high-level political forum. So thank you. And so we'll close the session for now. I will just ask the presentators and the team to stay online for a quick debrief. And otherwise, I will wish you all a great evening or afternoon. Bye, everyone.